What if I told you there's a single number, just one, that dictates everything from a global pandemic to a viral meme? It sounds like something out of a sci-fi movie, right? But it's real, and it's maybe the most fundamental concept in all of biology.
So what is this number? This one single value that literally decides whether something spreads like wildfire or just fizzles out.
All right, the answer is a term you've probably heard a million times by now, R naught. But let's be honest, what does it actually mean?
Okay, so at its heart, R naught, or R0, is actually super simple. It's just the average number of people that one sick person will infect. But, and this is key, it's in a population where nobody has any immunity. You gotta imagine a virus dropping into a totally fresh, unprepared environment. So, if one person gets sick and infects 2 other people, boom, the R naught is 2. That's it. And this is where everything hinges on the number 1. It's the magic number. If R naught is anything greater than 1, an outbreak grows. And it doesn't just grow, it explodes. But if it's less than 1, the outbreak peters out and dies. That simple line in the sand, above 1 or below 1, it's one of the most basic, fundamental rules in the math of all life.
But here's what you really need to get about R naught. It's not some fixed, unchangeable number that a virus is born with. It's not hardwired into its DNA. No, it's an outcome. It's what happens when a pathogen, the world around it, and, most importantly, us all interact. And that means we can actually change it.
So how do we change it? Well, we've got to look under the hood. R naught is basically built from 3 key ingredients, all multiplied together. Think of this formula as the engine room, the thing that's really driving the whole outbreak.
Okay, so let's break it down. First up, you've got beta. That's just a fancy way of saying how easily the bug jumps from one person to another. Super contagious? High beta. Then there's K, which is all about contacts. How many people do you bump into? A packed subway is a high K. A quiet farmhouse is a low K. And finally, there's D for duration. That's simply how long you're walking around being infectious. Easy, right? And this is where you can see that R naught is so much more than just biology. It's like a mirror reflecting our own society back at us. When we go to concerts or pack into stadiums, we're cranking up that K variable, the contact rate. When we hop on a plane, that's technology helping a virus go global. Heck, even the ventilation in your office building can change beta, how easily the thing spreads. Our choices directly build this number.
Okay, so we've been talking about diseases this whole time, right? Well, get ready, because this is where the whole idea just expands. It gets kind of mind-bending. The very same logic of R naught, it applies to pretty much anything that spreads.
Just think about it for a second. An invasive weed taking over a field, its R naught has to be bigger than 1. That meme you saw everywhere last week, it went viral because its R naught was greater than 1. It works for cancer cells growing in a body, a new species finding a new home, even for new technologies catching on. It's the universal code for growth, for replication. All right, so let's bring this back from the abstract and look at some real-world examples. Let's talk about some actual numbers that have totally shaped our world. 15. Just 15, that's the rough R naught for measles. We're talking about one of the most infectious things known to humankind. One single person can on average infect 15 other people. That is just staggering.
And to really see what that number means, take a look at this. The regular old seasonal flu, it's down here around 1.3. The original strain of COVID-19 was around 2.5. And then, all the way up there is measles at 15. It's not even in the same ballpark. It's a completely different level of contagious. The growth is just explosive.
Okay, so why is this so important? Why do we care so much about this one number? Because R naught is the magic key. It unlocks the answer to one of the biggest questions in public health. How do you stop it? It gives us the herd immunity threshold. It tells us the exact target we need to hit to shut a disease down for good.
And you know what? The math here is surprisingly simple. You don't need to be a genius. The percent of people who need to be immune is just 1 minus 1 divided by R naught. That's the whole formula.
So let's plug in the number for measles. You take its crazy high R naught of 15, pop it into that formula, and this is what you get. You need to have something like 93 to 95% of the entire population immune just to stop it from spreading. That's why vaccination efforts for measles are so important. The wiggle room is practically 0.
And this number, it's not just some modern lab curiosity. It's been a powerful force throughout all of human history. Think about the Black Death. Its R0 was cranked up to 11 by crowded, dirty medieval cities. Or smallpox in the Americas, which was so devastating because it slammed into populations with absolutely no immunity. R0 has been the silent engine behind some of history's biggest turning points.
So, let's pull all this together. What's the big takeaway? Why does this one number matter so much? Well, because it's more than just a number. It's the bridge. It's the connection point between the cold, hard logic of math and the messy, beautiful reality of life. Right now, as a species, we're in this constant tug-of-war. On one side of the rope, you have things like global air travel and massive megacities, which are always trying to push R0 higher. But on the other side, we're pulling back with our most powerful tools: vaccines, clean water, modern medicine. It's a constant battle.
And believe me, the stakes are incredibly high. The difference between an R0 of, say, 0.9, where an outbreak just dies, and 1.1, where it becomes a global catastrophe, is vanishingly small. It's a fight happening on a razor's edge.
So no, R0 is not just some obscure number for scientists in a lab. It's the language that life itself uses to talk about growth. It is the fundamental rule that decides if something takes off or if it simply fades away.
It helps us understand not just pandemics, but the very nature of life. So I'll leave you with this to think about. If R0 really does govern all kinds of growth, from viruses to viral ideas, what do you think is getting ready to spread next?